Mr. Ainsberg here with help for the non-calculator portion of the Chapter 5 test, which really deals with logarithms. This is where a lot of our stuff with logs comes into play, and even exponents. And the first concept that's going to be on the non-calculator test is evaluating a logarithm. So just think, what does it mean to evaluate a log? Well, a log of a value is always equal to a power. So I'm really trying to find powers. A big thing here, so I have this idea of what's the concept written down, but I also have what's the process you want to use. When you are evaluating logs, you want to convert to exponential form. And so let's kind of first talk about that, because some of you may be still having some problems with that, is if I have a log, I'm going to have some base, a number, and a power. So b for base, n for number, p for power. So log base b of n equals p, log of a base of some number equals a power. What's the exponential form? Well, you can use the same letters. I have a base, I have a power, it's going to equal a number. So, I mean, this is it. You can memorize it, just the structure of it, and realize what goes where. You can ask the question, hey, what power of b gives you n? And that's p, so I can kind of say what power of b gives me n. Well, b to the p power gives me n. We've looked at it that way. You could even just do it by following steps and just memorizing one little thing, and you know b is the base. So we can do something called the bump it technique. And some of my other classes we looked at this is, if I know that's my base, I can take that base, slide it over, and bump that power back to the exponent. Now let's see if that actually works. So I can take my base, which is right here, I can slide it over, and it could bump that power up there. So now we're in exponential form, right? So then I don't need this log anymore. It can go away. So it does work. So you could just circle the base and go bump it and bump that power back up, and that's going to get rid of the logarithm. So I'm going to use that technique here to kind of reinforce something for those of you who are struggling. So here's three of them. No calculator. It's just there for decoration. So here we go. What does a log equal? A log equals a power. So I'm going to put equals p. I could read it left to right. What power of 7 gives me 343? And then create my exponential form. Or I could try the new technique. That's what I'm going to. I'm going to circle the base. I'm going to bump that exponent up. So it's going to be a 7 to the p power. 343, since I'm in exponential form, poof, the log goes away. What power of 7 gives me 343? I have to find that. That's my p. But I'm expected to know 7 beyond 7 squared is 49, and you can. Maybe it's not memorized, but you can. If you know 7 squared is 49, then you're going to multiply that by 7, and that's going to give you 7 cubed. Now, if I think of 49, 49 is really, really close to the number 50. So here's what I'm going to do. I'm going to multiply 7 times 50, which is just 35 and add a 0, and then subtract 7. It's applying the distributive property. So that's 7 squared times 7. That's 7 cubed. So I know 343 is 7 cubed. Look at that. The bases match. They cross out. The power is 3. Now listen to how I said that. The power is 3. What power of 7 gives me 343? It's like you're translating it. Now in this case, I did something besides just trying to make up a number or just say, oh, the answer is 3. I created something called common bases. If you look at the list what's on the non-calc as well, solving exponential equations using common bases is also on the non-calc. So I did this intentionally to practice this more. What about the second one? There's a fraction, but we're dealing with exponents. So what does that mean? If I have a fraction with exponents, does that mean I have a negative exponent? So let's keep that in mind. I have a fraction, probably going to have a negative exponent. So I'm reading log base 9 of 1 over 729. Really means what power of 9 gives me 1 over 729. I need to find that. I could translate it, or I could go, there's my base, bump it. So 9 to the p equals 1 over 729. And again, you may ask yourself, seriously, Mr. Ainsberg, I have to know powers of 9 beyond 9 squared is 81. Well, if I know 9 squared is 81, let's see what happens if I multiply that by 9. You know, this multiplied by 9 is not bad, because 9 times 1 is 9, and 9 times, no carrying, 9 times 8 is 729. It just happens to be cubed again. They're not all going to be cubed. In this case, I know that 9 cubed is 729 now. So I'm doing this on purpose. I want you to realize even if you don't know, then pick the one you do and just try and quickly multiply. 9 cubed, but it's a fraction. We said negative exponent. So that'd be 9 to the negative third equals 9 to the p. So what power of 9 gives me 9 to the negative third? Well, they have the same base. I'm actually telling you the power. The answer is negative 3. So what power of 9 gives me 1 over 729? Negative 3. So there's the bumping technique, kind of going through, creating common bases, crossing them out, a skill that's needed also for the NonCalc. Now, the reason why this one's highlighted is because I'm taking the time to make this video, which means, by the way, I want to have some fun. So I'm doing a fraction. And so I have this equals a power. So I am going to bump the 4/5 over. So I get 4/5, that whole fraction, I have to put in parentheses, to the p power. I convert it to exponential, so the logarithm disappears, and I'm left with this, and I get to go, yuck. I need to know 625 or 256. What is that a power of? Which one, which one, which one? And I'm going to choose 625. And the reason why is because it ends in a 25, so I know it has to be a power of 5. And just think in the grand scheme, and I didn't talk about it here. I'm not going to make extremely high numbers like the 8th, 9th, 10th power when it comes to non-calculator. I'm not going to give you rationals or decimals saying you better know what 2 to the 3/5 power is without a calculator. No. They're going to be nice integers you should be able to do. Not really large integers. They'll be nicer ones, smaller ones. And so that's kind of what's going through my mind with 625. Is I have to kind of think about it. Now I want to figure it out. Let's see. I'm going to choose 5. Well, I know 5 cubed and 5 squared. 5 squared is 25. If I have 5 quarters, I have $1.25, so there's 5 cubed. Now, what if I want to do 5 cubed times 5 again? Well, let's see. I can do 100 plus 25 and multiply that by 5, and I get 500. 5 quarters is 125. I do get 625. So I know that 625 is 5 to the 4th power. Question is 4 to the 4th power 256? Now, here's the quickest way, by the way, to do the 4th power. Square the number, so 4 squared is 16, and then square that number, multiply it by itself. 16 times 16 is going to be 256. I could do it the way we did in elementary school, like you can see there on the side. I could also, by the way, do the area model, 10 plus 6. Oh, by the way, I could do 10 plus 6 times 10 plus 6, couldn't I? I could do 100 here, 60, 60, and 36. So I can even use the area model without variables. That's the idea behind it. Variables are used to represent numbers. So can I use the same techniques? So that's if you're ever stuck, what you're supposed to do. But there's a better way of writing it. I'm not going to do each one to the 4th power. I mean, the whole thing is being raised to the 4th power. I'm going to make it look like the right-hand side. So this says 4/5 to the 4th power equals 4/5 to what power? Bases match. Lo and behold, the power is 4. And so that's how we go about it. That was for me. I want to have some fun since I'm taking time to make a video. Now, there's the concepts. Again, if you struggle with evaluating logarithms, the idea is to convert to exponential form. You can learn the question we've dealt with, or you can learn the bump it technique. Circle the base, slide it over, bump that power up. Now you're an exponential, get rid of the log. So there's the first concept. Second concept, creating common bases. So I said we're going to kind of be working on this one. So I have to look at this. Now I'm going to kind of go through this. We kind of looked at it in the previous example, is if you have the same base on both sides, they can cross out and you can deal with the equation and the exponents. 25 and 125 don't have the same base. But I'm going to kind of pay attention to this. I always look at the smaller number first, the smaller base, and I think about powers of it. Well, 25 to the first is 25. That doesn't equal 125. 25 squared is 625. I'm way beyond 125. So I can't change 125 into a power of 25. It doesn't work. And so in that case, what I need to do is I need to change both numbers. I still look at the smaller one. I'm still going to look at 25 there because it's smaller. It's easier to figure out what it's a power of. I know 25 is 5 squared. I still have the negative x minus 3. Well, we did look at it in the previous example. We already figured out that 5 cubed is 125. So they do create, I'll make it look like the other side, they do create the same ones. So I'm going to cross out just the bases, not the exponents. They have a common base. So I'm going to have 3 times 2x minus 1 equals 2 times negative x minus 3. Now, if you think that's going to look bad, let me go ahead and fix this. I like to put the parentheses around what the original exponent is, because then I can kind of see the distributing, and I'm not tempted to cross anything out. I can see 3 times the quantity 2x minus 1, 2 times quantity negative x minus 3. Well, now it's an easy, right? I just distribute. And I'm going to combine like terms. I'm going to add the 2x over here. I'm going to add the 3 over here. And I get x equals negative 3/8. And since you're dealing with an exponent, you are allowed to have negative exponents. We learned that before because it means a fraction. Now, there we are. That's it. Create a common base. Start with the small number and figure out what it's a power of. If you can't do it right away, do that. Now, in this case, I can do it right away. I realize that I have a 7, and yes, it's 1 over 49, but what did we say before? We said when we see that fraction, that means you're dealing with a negative exponent. So I'm going to keep that in mind. Which, by the way, 49 is 7 squared, so shouldn't this right away be 7 to the negative second? And I'm going to do what I like to do, which is put the x plus 4 in parentheses. And I'm going to put the, well, you know what, I don't even need the parentheses on the 5x minus 1 because there's nothing being distributed to it, so I'm just going to go like this. That was easy. Just have to remember fractions aren't intimidating when it comes to exponents. They just mean negatives. And then I just cross them out. And I'm going to go ahead and skip another step. I'm going to distribute it this time. Negative 2x minus 8 equals 5x minus 1. Add. Ooh, this one, I just made up numbers, and it worked out really nice here, right? And I get x equals negative 1. Perfect. So, create a common base. Technically, this is, by the way, the 5th time we've done this in the video because I did it on the previous concept because I know how important it is. So I want you to understand, please, understand common bases. If you're stuck on it, you just got to try it like I did in the other video. Just kind of keep raising to a power, multiplying, and see what you get. Again, notice, these weren't extravagantly large powers, were they? 5 cubed, third power. 7, squared, negative 2, of course, but second power. I'm not going for 8th power, 9th power, 10th power. They're going to be reasonable for you to grab without a calculator. But I'm taking the time to make a video, which means I want to have some fun. Now in this case, here's the fun. The fun is a tip. What squared numbers, cube numbers, and fourth powers really should you have memorized in case, at this point in pre-calculus? And I say this based off of how often they pop up, or you're going to be asked to square root a number, fourth power, or fourth root it. It's really nice to kind of know some of these. Now, I am going to say we're going to start with the number 1. Even though 1 squared, 1. And you want to know 1 squared all the way up. Not missing or skipping to 16 squared. Those 1 squared all the way 12 squared, 13 squared, 14 squared, 15 squared, 16 squared. Those pop up often. You think about Pythagorean theorems and stuff like that, those do. Now, some other ones that really, besides that, you should probably know, anything that ends in a 0, you should really know what squared is. So 20 squared, 30 squared, 40 squared, 50 squared, that should be possible as well. If I know what 4 squared is, 16, I'm going to add on 2 zeros because I'm squaring really a tens place, so it'd be 1600. 5 squared is 25, so 50 squared, I'm going to add on 2 zeros, it's 2500. So you should know anything that ends in a 0 as well. Memorized. The ability, when I say memorized, be able to find them fast. Really, really fast. 25 squared pops up a lot. That's 625. You've probably seen in this video, it's popped up a couple times already. Those are the ones you really should know. Cubes. 1 cubed, you can do it. 2 cubed, all the way up to 6 cubed. If you can't remember what 6 cubed is, do it fast. 36 times 6. That's 180 plus 36, 216. Look at that. I did the area model really quickly to remember what they are, and I try to be smart with how the multiplication worked. All right, so those you need to know. Besides that, 7 cubed, we had it in the video. I was kind of stretching there. If you realize it's 350 minus 1, you could do it. So 350 minus 7, you could do it, but that's kind of pushing it. 8, anything like 10 cubed, you should know. 11 cubed's fun. Don't worry about it. So we go through, I think that's it, really. And even, by the way, anything that ends in a 0 up through 60. I mean, 60 cubed. You really expect me to be able to do 60 cubed without a calculator, not quite memorized, but fast? Yes. Cube the 6, and then put 3 zeros afterwards. 216,000. So, it's possible. Same thing. 4th powers. 1 to the 4th power. Again, you can do it. 2 to the 4th power. 3 to the 4th power. 4 to the 4th power. 5 to the 4th power. And any of those numbers with a 0 at the end. Now, again, the quickest way to raise something to the 4th power is to square the number and then square it again. So 4 to the 4th power is really 16 squared. And wait a minute. I see that there. So if I have memorized 1 squared all the way through 16 squared, and I kind of memorized this, do you see how 4th powers aren't that bad? Because they're squaring a square. So there's a reason why I say these are ones you should really have memorized with squares. Because if you cover all of those, you're actually covering all of these. And it covers both squareds and 4th powers. So there's a reason why I say 1 squared through 16 squared, anything ends in a 0, or 25 squared. So that was my tip to help you out. Since I'm making the video, I wanted to have that fun. I'm talking about some nice non-calc tips. Concept 3 on the non-calc. Concept 3 is combining logarithms. What process do we use? That's the properties of logs. Notice it says combining. You'll see it also in the word could be condense. What that means is you take multiple logs, log plus, log minus. You merge them into one single logarithm. That's what combining is. You're going to combine into one log, which means you're not crossing out logs. You're combining into a single log. How do I do that? Properties of logs. What are logs again? Logs are always equal to, so if I think, what does a log equal? A log equals a power. A log equals an exponent. My properties of exponents say that if I'm adding exponents, so let me show you this. This is really equal to an exponent. Correct? This, now I'm going to talk about how to do it before. I'm not going to deal with the whole thing yet. This is really equal to an exponent. Intentionally, I left off the 3. Keep that in mind. I did not include the 3 there. Doesn't this say I'm adding exponents? When do I add exponents? Well, when I multiply like bases. So I'm going to combine using multiplication. And so that's what I'm going to have to keep in mind. So when you're looking at it, that's really what that's telling you, is you're taking 2 exponents and you're adding them. So you better combine, they're combined by multiplication. But notice I did not address this 3. This 3 is a coefficient. This is your power rule. And think about this, if I write this as power, which comes first when it comes to, wait a minute, what's that on the very bottom of the screen? Order of operations. We have to keep in mind our order of operations when we're condensing logarithms, is that it matters which ones you're dealing with, because we're looking at multiplication by combining, we're looking at division by combining, we're looking at exponents, which means I have to keep in mind my order of operations for these. Well, which comes first with order of operations? Exponents, powers, or multiplication. And first are exponents, are powers. So I am not going to combine with that plus sign using multiplication yet. I am going to take this power and I'm going to bring it up. So it's log of 2 cubed. So no coefficients. You know what? I know what 2 cubed is. Ba-boom, ba-boom. And that gives me 2 cubed is 8. Alright, so now I'm left with just this multiplication. And I have to combine by looking at multiplication. So in this case, I'm going to combine them. I'm going to do, and I'll show the work. I have my parentheses, and I'm going to multiply the numbers 7 and 8 together, which gives me 56. So, log of 56. These two are equal to each other. The big idea, I mean, you have this process, and you have the concept that's on there. But the big idea is to recognize your order of operations. That you can't just go left to right. You're dealing with evaluating something, combining them. So I have to combine using order of operations, like I always do. So do keep that in mind. I say that because look at this one. This one I'm going to kind of circle and do the same thing I did before. I see a coefficient. I see a coefficient. So that's a power. Let me get rid of this power right here so we don't get confused. And that's a power. Then I have this right here. I'm subtracting powers. When do we do that? We do that with division. So which comes first? Does exponents come first? Or does division come first? In this case, exponents do. So I'm going to combine. I'm going to do this. I'm going to bring that 6th power up to this exponent. I'm going to bring this 4th power, whoa, up to that exponent, but that's a little weird, isn't it? I have an a cubed, and I'm bringing a 4 up here. What am I end up doing with those? And well, you're taking a power, and you're multiplying it to a power. So this gives me log of a to the 6th minus log of a to the 12th. And now I can focus on my division. So, by the way, what did we just do there? We took a power from the front, and if there's something already there, you're going to multiply it to combine them together. But Mr. Raisberg, you didn't do that before, didn't I? If you don't see an exponent, isn't the exponent 1? Isn't 6 times 1 6? We did do it before. It's just harder to see because we don't show exponents of 1. All right, but I digress. We are going to merge these together into one single logarithm by doing division. And you may go, I am done, but no, you're not, because this can be combined as well. And always, 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 always simplify your answers. So a to the 6th over a to the 12th is 1 over a to the 6th. And there you are, combined into a single logarithm. And I said the tip here is order of operations. I'm not going to go into anything more than that because I went into that tip during these examples right here. So, last concept, solving logarithmic equations, and that's converting to exponential form. That's the same process as the first example I went over. And notice in this example too, we created common bases to solve. That's interesting. We're actually applying 2 of the skills we've already addressed in this process. So, I'm going to do this. Now, I've said before, you can, in your work, change ln to log base e. That's fine. But in your final answer, if there ever is log base e, you have to change it to ln, because that's mathematical language notation. A shortcut is I'm going to show the base. I'm not going to change the ln. I'm just going to put an e here. I know ln has a base of e. Well, how do I solve for x? Again, I could go left to right. What power of e gives me x minus 7? The power is 9. I could translate it. Or we could bring back from the beginning of the video the bump it technique. Take the e, bump the power up. E to the 9th power equals x minus 7, because I converted exponential form. The log goes poof and disappears. Well, this isn't bad. X equals e to the 9th plus 7. I add 7. And there's no calculator. I'm looking for the exact answer, and that's it. You don't need to know what e to the 9th is. Just treat it like a variable. It's an irrational number. Can't do anything to it. That's all I needed to do. So we converted to exponential form, bump it technique, the first set of problems that we did. And then, well, this one actually I didn't need a common base. So it turns out I didn't need a common base. I just needed to solve. What about this one? Again, what power 7 gives me 2x plus 1? The power is 2. I can convert very quickly if I understand how to read it. If I don't understand how to read it and I want steps, what I'm going to do is I'm going to go ba-boom, ba-boom, and I'm going to bump it. And that 2 now goes up to the exponent, and the base is 7, and I get 2x plus 1 equals 7 squared. The log disappears, poof, because now we're in exponential form. By the way, 7 squared is 49. I would subtract the 1 and get 48. X equals 24. By the way, check your answer. If I plug it in, what can't you take the log of? Negative numbers. If I plug in 24, it does work. By the way, look what happens if I plug in 24. 2 times 24 is 48, and I get 49. What power 7 gives me 49? 2! It gives us the answer. That's amazing. All right. Now, again, because I'm taking the time to make a video, I want to have some fun. Here we are. Intimidation. Log base 3 of the quantity x squared minus 3x minus 1 equals 2. You may be freaked out. But even something like this is still the same idea. And I'm not going to do the whole what power. I'm going to circle the base, and I'm going to go bump it, and I get 3 squared equals x squared minus 3x minus 1. And I have right there a quadratic. The log goes away, poof, because we went to exponential form. Well, quadratics are set equal to 0. 3 squared is 9, and so I'm going to do -1 minus 9, that's -10. That's not a bad factor. X minus 5, x plus 2, what multiplies to -10, adds to -3. So I get values of x equals 5 and x equals -2. Awesome. I could box and circle those and plug them in. No. I have to plug each of those numbers in there to see what happens. If I plug in 5, I'm going to get 25 minus 15 minus 1. Do I get a positive number? Yes. By the way, what number do I get? 25 minus 15 minus 1 is 9. What power of 3 gives me 9? 2. How many powers of 3, by the way, give you 9? Just 1, right? 2. 2. 3 squared is the only way to get 9 from 3. That's interesting. Now, why are you asking that? Well, I'm asking that because of this. Why do I have a second answer then? Now, either when I plug in -2, it better give me 2. It better give me the way to get 2, 3 squared. It better give me a 9 in that case. Let's see what happens. If I plug in -2, -2 squared is 4. 3 times -2, positive 6. So I have 4 plus 6 minus, it does give me 9. Isn't that interesting? So I'm not actually taking the log of a negative number. I'm taking the log of a positive. So this has 2 different answers. Just because your variable is negative doesn't mean you cross it out. You have to plug it in to make sure what you're taking the log of is positive. That was me, of course, having some fun. These are the concepts and the process. Some of these had some tips. Some of these was me entertaining myself because I'm taking the time to do it. But do keep these in mind. Hope this helps, and good luck.